Hi, my name is Bereneice Sephton and I'm with the University of Witwatersrand. I study Masters in Physics over there and we play with optics and have a lot of fun with it. So over here I have the answer to a lot of questions that we ask our parents when we're small. And that question is, why is the sky blue? So this is a really important bottle. But when we think about the air around us and we think of clean air, right? We don't think of there being anything in it, it's clear. So it's like this water bottle over here, you don't see anything inside. But life isn't perfect. So the wind blows, we get dust particles inside, maybe there's a lot of smoke as well. And so what happens is we have these little particles floating around in the sky around us, and it's almost like taking milk. So this is a little bit of milk. And we know that milk has fat particles floating around it in water. So when we take this, right, and we put it inside this water bottle over here and we shake it up, we've got this, So this is our sky with particles floating around it, right? And if we put it down over here and we think of our sun is made out of some primary colors, right? Like red and blue and green. So red has a very long wavelength. So now we're going to see what happens if we put a long wavelength through a sky with a lot of dust particles, okay? So if we look over here, we see that it stops round about here, right? And it gets absorbed. What happens if we go a little bit shorter? So green is a little bit shorter than red in wavelength. So we look how far it goes round about here and it gets absorbed, right? But if we look at blue, which is a very short wavelength, and we put it in our sky with the dust particles, we see it goes very far. But if you look here really carefully, that's not quite blue. That's actually violet. So we've actually been asking the wrong question the whole time. The question we should have been asking is, why is the sky violet? But we can't see the violet because of the way our eyes work. We're more sensitive to blue. So when we look at the sky, we see blue when it's actually violet. And so if we look at our sun, and we can think of it as a combination of all of these colors, so we can start with the first two colors, you can see how they're over there. And when we add just a little bit of blue, it completely disappears and we get our violet sky.
So hi, my name is Issac Nape, and I'm from the University of the Witwatersrand, and I'm representing the WITS Optics group. So what I'm going to explain here now is how your basic lenses in your cameras actually work. So what I'm doing is I poked two dots in this little tin foil, which I just picked up. You can get it anywhere. And I then used two lenses to image it onto a piece of paper. As you can see, when you look in closer, these two slits are actually imaged onto this paper. Now, the question is, we know that lenses or other 4F systems, when imaging, invert images from up to down. The question is, does it also invert them from right to left? What do you think? Let's see, perhaps nature might have something interesting to show us. As you saw now, I covered the hole that is closer to me, and on the paper we see that the one that is furthest to me disappears. So that just means that the image in this plane travels through the lenses, gets converged, the two rays cross, and then they inverted in the image plane. So that explains how your lenses work at home. Thanks.